Okay, you guys, for this video segment, I'd like to talk about covalent compounds. We've got two different types of compounds that form based on the electrons, and one of those is covalent. And in a different segment, we'll talk about ionic, which is the other type of compound that's created. So first, you guys, in terms of covalent bonds, generally covalent bonds, we've already seen this a little bit. Two nonmetals shown right here. So when I look at this, carbon is a nonmetal and hydrogen is a nonmetal. And so when we see two nonmetals, generally speaking, that is a covalent bond. Oh, come on. Why are you trying to erase again here, and I'm not sure why. There we go. So in terms of nonmetals, in order to become full, remember we talked about this with valence electrons, hydrogen, and it's looking for one more, and so hydrogen needs a total of two. So hydrogen wants to add one electron. Carbon equals 4 valence electrons. And so carbon wants to add 4 electrons. So they're both looking to add. So we'll see ionic bonds are a little different, and one wants to lose, one wants to add. But in a covalent, they both want to add. So right here, we see the reds. That's a hydrogen electron, and the blues are a carbon electron. So right here, hydrogen starts to use an electron from carbon, and that gives that hydrogen 2. And we see that process repeat itself 4 times because our formula for this is methane, 1 carbon, 4 hydrogen. And so we see that process repeat itself 4 times with the hydrogens. And so now in terms of hydrogens, each of those hydrogens are stable. Each of those hydrogens gain that electron. And so now the hydrogens are stable, but the carbon also is sharing those electrons. And so now carbon has 1, 2, 3, 4, 5, 6, 7, 8. So by a process of sharing electrons, hydrogen has 2. Each hydrogen has 2. And the carbon has 8. And so sharing those electrons, a bond is formed, and all of those elements are now considered stable. Remember, we talked about being stable and having a full outer energy level. So covalent bonds, it can happen with 2 of the same elements. If we look at this picture up here, our formula here, O2, we see these electrons in the middle. Those are shared with the oxygens. So this oxygen has 1, 2, 3, 4, 5, 6, 7, 8 electrons in the outer energy level. And this purplish looking one, 1, 2, 3, 4, 5, 6, 7, 8. And so now by sharing those electrons, that element, or that compound, I'm sorry, is now considered stable, and each has a full outer energy level. If we look at the formula for water right here, 2 hydrogens, 1 oxygen. If we look at the hydrogens, full outer energy level, 1, 2, and 1, 2. So those hydrogens have what they're looking for, but the oxygens as well, 1, 2, 3, 4, 5, 6, 7, 8. And so now that is a stable compound. That's water. We, of course, need that to survive. But each hydrogen has a full outer energy level, and the single oxygen has a full outer energy level through a means of sharing electrons. And that's what we've got with a covalent bond. And so covalent compounds, you guys, just some of the properties about them. They're called molecular compounds. That's just another word you might see for them. They can have many, many atoms combined together. You see this molecule for caffeine. There it sits. That's in coffee. That's in a lot of the sodas we drink. Energy drinks that we consume. The caffeine right now seems to be really popular in a lot of the things we have. But then you look down here, it can be as simple as just two atoms together. This is hydrochloric acid. That's the acid found in our stomach, helps us with digestion. So as simple as two elements together, or it can be many, many, many atoms together like caffeine. And you know, somewhere in there, they're all sharing electrons. Properties of these covalent compounds, they burn pretty easily. They do not dissolve in water. Some of them will, but don't dissolve in water. They're not very good conductors. They have low boiling points, and they are liquids or gases at room temperature.